moving into our second unit of the year. No longer completely totally review material. We're moving into quadratic functions. Some basic information here about quadratics. Any quadratic can be written in the form y equals ax squared plus bx plus c. That's what's called the standard form of quadratic. The basics of a quadratic graph is that it's U-shaped. It's called a parabola. The lowest or highest point is called the vertex of the parabola. And the axis of symmetry is the vertical line through the vertex. We will find a lot of similarities here, especially over the next couple of days, between graphing parabolas and graphing absolute value functions. They're very, very similar in a lot of ways. These are the basics. We're going to see these in a couple of graphs we do. Two of the most basic parabolas, y equals x squared and y equals negative x squared. These are parabolas centered at the origin. Okay, the vertex here is the origin. So if we want to think of a t-table, x and y, when x is 0, y is 0. When x is 1, y is 1. So 1, 1 is on our graph. When x is 2, y is 4. 2, 4 is right here. When x is 3, y is 9. So 3 and 9 is on our graph. You can see this is growing very, very quickly. Now, we can go in and plug in -1. We get 1. -2, we get 4. Or we can use the axis of symmetry. This is the vertex. The y-axis is an axis of symmetry here. So if I go to the left of the axis of symmetry 1, I have to go up 1. These are going to be mirrored the entire way up. That's the basic outline of our graph here. So when we draw it, it looks like that. Right there. U-shape opens up. Again, the coefficient is positive, that's why it's going to open up here. If we take a look at the second one on the right here, it's our x and our y. If I have x is 0, y is still 0. So our vertex is still the same, still 0, 0. Now, however, if I do 1, 1 squared is 1 and the opposite is -1. So 1, -1 is on this graph. If I put in 2, 2 squared is 4, but the opposite of that is -4. So I have 2, -4. And then the same thing with 3. 3 squared is 9, the opposite of that is -9. So we're down here. And again, we can use -1, -2, -3. But again, we can use the axis of symmetry as well. We can mirror each other all the way down. And then this is U-shaped, but it is opening down. So again, it opens down because of the negative out front. So it's something that carries us over from the absolute value function. With these basics, let's describe any graph here. We consider ax squared plus bx plus c. It will open up or down. It opens up if a is positive. It opens down if a is negative. That is something that is the same as the absolute value functions that we've seen already. It will be wider than the parent function, which we just saw, if a is between -1 and 1. Again, the same as the absolute value function, as is when it's narrower. This would be a narrower graph if a is less than -1 or a is greater than +1. Those things, those concepts are the same as what we've seen with the absolute value function. That hasn't changed. A couple of new things though, the x-coordinate. To find the x-coordinate of the vertex, you take the opposite of your b, which is the coefficient of x, and you divide it by 2 times A, which is the coefficient of x squared. So that will give us the x coordinate of the vertex, which will help us find the coordinates of the vertex, help us find the y coordinate as well. Then the axis of symmetry is the vertical line x equals that, because as we saw back in our definition there, the axis of symmetry is the vertical line that goes through the vertex. So it has to have the same x value as the vertex point. So this description, probably the most important information you can write down here on your notes. Make sure you have this down. Pause it, rewind it if you need to here. We're going to look at a couple of examples on the next 2 slides, I think. 1 for 2. We describe this graph, okay? This opens up. This is narrower. Okay, this is because 2 is positive. This is because 2 is greater than 1. That's where that information comes from. Now our x coordinate of the vertex, x is equal to the opposite of b divided by 2a. So the opposite of b will give us 8 over 2 times 2. So we get 8 over 4. We get 2. So that is the x coordinate of our vertex. The one most important point that we'll need to find in these is the vertex point. We have the x coordinate of that. So now I can plug that back in to my original equation. So I have y equals 2 times 2 squared minus 8 times 2 plus 6. 2 squared is 4 times 2 is 8. 8 minus 16, this is negative 8 plus 6. We get negative 2. So our vertex point is the point 2, negative 2. Right there. So we can also think that's our axis of symmetry right there. X equals 2. So now we have to go about graphing this. Think of our table of values. We want to start at 2. Let's go. Sorry about that. Let's pick up here. We need to start with our vertex point, which is 2, negative 2. So when we come and make our little table of values here, our x, y, I have 2, so I want to go here to 3, and let's try 4. And let's just go with those. So when we have 3 squared, that's 9. 9 times 2 is 18. 18 minus 24 is negative 6 plus 6. We're going to get 0 there. So 3, 0 is right there. Let's try 4. 4 squared is 16 times 2 is 32. 8 times 4 is 32. Those become 0. We get 4 and 6. So 4 and 1, 2, 3, 4, 5, 6. So we have those 2 points. Now we can use the axis of symmetry. And this to the left here, 1. We go up here to 6, and it's going to be left to there 2. Hopefully we can see this is a little narrower than our parent function. And we now graph a parabola. And that's it. That's how we would go about doing that. Our description, our important information, our table of values, plot those couple points. Always start with the vertex. It helps us use that axis of symmetry. I'm going to pause. We don't have to do this example. We'll call it a night. We're already at 10 minutes here, so we'll pick up with these tomorrow during class, and we'll go from there. Have a great night.